Right, so we're going to talk about JavaScript, and there's two, let's say, perspectives when talking about JavaScript. The first perspective is going to be a more traditional one, which we're going to adopt today. But languages are not their syntax. Languages are the mechanisms that I can use to solve problems in said languages. Moreover, while our applications have become more complex, the utility of a language is highly dependent on its ecosystem. Right, so there's that. That being said, we're going to start with the hello world, right, which is already a bit strange, in the sense that, sure, it writes hello world. By the way, I pressed the magic key of 12, so we can also always have something to run our JavaScript if we want to. And we run it. Now the strange bit here is that apparently console is an object. It has a method called log, and it received the parameter, which is a string. But where did console come from? Right? The idea is that the interpreter, wherever the interpreter might be it in the browser or in a command line, is going to have some global objects which have been automatically defined. Now these objects are dependent on the context I'm in. So because I'm in the browser, for example, I'm going to have a window thing, and I'm going to have a document thing, and I'm going to have a history thing. Right? So there's a bunch of global objects. Obviously, these would not work in a console application, but they do work in my browser variant. Now, I said that there's a traditional way of looking at languages, and the traditional way is going to involve looking at the types that JavaScript supports, having a brief chat about operators and about control structures. Now, something to remember is that when JavaScript was designed, even though the spirit of the language is really different from the language it copies, the syntax was designed to be familiar, and at that point in time, that meant the syntax is really similar to C. Right? So it's C, but with dynamic types, the syntax. Now, there's a bunch of things that are different, and we're going to comment on them. However, we're also going to send very much to C, so we're not going to go through everything. We're just going to say that the switch works just like in C. Now, generically, the language is a multi-paradigm language. That means that I can solve a particular problem in different ways, think about the problem in different ways. Now, these have to be somewhat explained, so it's an imperative language that's, let's write code like we were 5th graders, just like in the old days, but it's also a functional language and an object-oriented language. Now, these need some mentions, because it's a functional language. What would a functional language entail? Now, you're going to see a lot of languages saying they're functional languages, but at a fundamental level, a functional language is a language in which functions are values. Right? So what the functions are values means is we're going to take a simplified approach. It's going to mean that I can use a function in any context where I would use any other value. Right? So if I can send a number as a parameter to a function, I must be able to also send a function as a parameter to a function. If I have expressions that evaluate to numbers, I must have expressions that evaluate to functions, and so forth. Now, this is a bit vague, and when we're going to get to the more in-depth talk about functions, we're going to see what this actually means, because what I've said is intentionally for now a bit unclear. So for now, let's just say that functions can be used in any place that the value might be used. Right, object-oriented. Now, it's an object-oriented language. What's interesting or what's special about this is that it's an object-oriented language on a model different from all other mainstream languages. Right, so mainstream languages, as a rule, are going to be what are called classic languages. They're called classic languages because they have classes. And to think about what that might entail, well, classic languages have a sort of blueprint of objects of the same type. And whenever creating an object, they're going to create it based on that blueprint. Right? The class is the blueprint, and all instances respect the blueprint. Now, JavaScript doesn't work like that. In JavaScript, as an aside, most things, if not everything, are concrete. Right? So there's nothing abstract. There's very few abstractions. Right? It's not. If I have access to a namespace is something concrete in memory. A library is something concrete in memory. It's an actual object. There's no abstract definition of a type. It's an actual object, which is the definition of the type. Right? So everything is concrete. Right. Now, it's an interpreted language, which means that I'm going to serve a bunch of text lines to a program which is going to run them. Right? It's not compiled. Well, it is not compiled in the sense that something like C is. Now, as an aside, even interpreted languages do some amount of compilation, but it's just in time. So things which are frequently used are compiled, and the compiled version is cached. It has dynamic types, determinable and modifiable at runtime. Now, these are things which are a bit different. So if I think about determinable at runtime, that's going to be type inference, right? I can have type inference in a variety of languages, even languages with static typing, right? So if, for example, I can do it in C#, for example. So in C#, I can say something like var L is some value. And the variable itself is, let's think about it as a box in which I place something. Right? So in this kind of perspective of type inference, what's going to happen is the box has the type of the first thing I put in it. Right? That's it. I just don't have to specify it. It's a ease of use thing. Well, in JavaScript, it's a bit more extreme than that, in the sense that the box has the type of what it currently contains, not what it first contained. Which means I can change the type however I want. But even in comparison to other dynamic languages, JavaScript is a bit more extreme than that, in the sense that I can change what the type means. Right? So if I want in JavaScript, we're not going to see this today because it's something a bit more advanced. It's next time. But for example, I might want in JavaScript to modify all strings, modify the behavior of all strings, whether they were previously defined or not. And I can do this. This is something I can't do generally in kind of almost any other language. Right? So I want to define a string and then modify how a string works. And I can do that. Now, we'll see that. So initially client-side, also server-side. Now, this means the language runs in various contexts. And on the client, we can see it right now. The console is open. On the server, I'm going to have a bunch of interpreters. We're going to use the most mainstream one, but there's multiples, right? So we're going to use Node. But there's also Bun, there's also Dino, and so forth. What's going to be different? It's going to be dependent on the context, right? So that means that what's going to differ is going to be the global objects that the interpreter created and the libraries they have access to. The reason for this is, for example, in the browser, if I really think about it, it's a bit scary, isn't it? I'm downloading something written by a stranger on my computer and running it. Now, obviously, this has to be sandboxed. Right? I can't have code such as this be able to arbitrarily read the file on my computer. It just wouldn't work. It would collapse in a matter of minutes, the whole internet. So it's sandboxed. So I don't have stuff like that reads a file. But obviously, in anything which is server-side, I am going to have libraries which just read an arbitrary file, just cause, or create an arbitrary file. Additionally, because I'm in the browser, like I said, I have a bunch of global objects. So I have something like window. Now, window doesn't necessarily exist in a console application. Right? It's not something that's going to be by default there. I'm also going to have some common stuff, such as console. Right? I have console everywhere as a debug mechanism. Right. Now, something to note here. So apart from this difference, the language is identical, but we have to mention something here, which is that the language is what is called the living standard. That means that the standard of the language is open, and I recommend, if you have enough time for this, to read the standard. It's readable. It's a readable standard. It's written for people. If you want a comparison, just read a couple of pages of the C++ standard, and you're going to understand the difference. Right, so this is written for programmers. It's not written for people who build interpreters. Right? So it's readable. Anyway, so it's a living standard, and because it's a living standard and stuff appears each year, you might have the situation where there's a feature which has not yet been implemented. Right? So how does the ecosystem go about that? Right? Because, like I said, languages are more than just the language, but also the ecosystem around the language. Well, in JavaScript, there's a bunch of solutions. So, for example, I can read the most modern code possible and pass it through a transpiler. Now, these are regularly used, and they're going to take my really modern code, which isn't runnable anywhere, and transform it into code which is runnable somewhere. But at some point in the future, V8, for example, which is the interpreter from Chrome, is going to support that particular feature, so I no longer have to transpile it. Additionally, if it's something even more alien, I can use a polyfill. A polyfill is a library which supplants some feature of the language, because even though we don't have the nicest, let's say, syntactic sugar in JavaScript, it's really easy to invent it. Right? So the language is characterized through the fact that I can, in terms of what I can program in the language, it's really easy to fill in the gaps. Right? If there's something which hasn't been implemented yet, or I want it, I can easily implement it. So for example, I don't have a syntax for functional decorators, but it's trivial to make functional decorators in JavaScript with functions. Right? I would like the syntax. I would like the nice characters. But apart from the nice characters, the thing is possible. JavaScript in general is a language which gives you a lot of freedom of movement, so to speak, freedom of expression. 1 second, because this, okay. Now, the language is fundamentally asynchronous. What does that mean, and how does this relate to everything? Well, if I think about the language which started from console applications, right, its initial target was console applications, at some point they wanted to make a graphical user interface library. And they ran into the following problem. Any graphical interface library has to repaint the screen continuously. Right? So if the language is synchronous, synchronous means that I get to a line of code, I start running it, and then I wait for it to finish running. Right, so if a line of code takes a noticeable amount of time to run, that's going to mean that I can't repaint, right? Right. Which means that there's a solution to this, obviously. The solution, because it's a trade-off, there's no ideal thing, right? It's all trade-offs. It's you give up something to get something else. This is called the no free lunch theorem, right? In this case, what I have to do is to have a separate execution structure that is a thread or a background worker or however I might name it, or a coroutine or whatever it is. And I'm going to dump the long-running operation on that, and that thing is going to be responsible to notify me when it's finished. Right? Okay, so that's a synchronous perspective. But JavaScript didn't appear in this context. It didn't appear to make console applications. It appeared specifically to automate things in the browser. So it's the graphical user interface was given. Right? It's not somebody designed a graphical user interface in JavaScript. The graphical user interface was there, and this automates it. Right. So in this case, you might opt to make a language which is asynchronous. Now, asynchronous means that I start running a line of code and then get to the next line without waiting for it to finish. Right? So this is how JavaScript works. Now, in order to have something like this, you have to have the language constructed around an event bus, something which supports events. And any instance of JavaScript you might run into is constructed around an event bus, basically. There's an event bus given. It's there, both in the browser, in a console application, on a robot, or wherever. Right, so the language is asynchronous. This comes with its own challenges, because let's say that I want to wait for the line to finish. Right. How do I go about that, right? Because I want to wait for it to finish because I need the result of the execution. I can't do that by default, so I need some mechanisms to handle this case. At this point in time, we have some elegant mechanisms to do this, which are async await. The mechanism is called async await, but when we're going to talk about asynchronicity, we're going to also look at the other ways of doing it, so to speak. So the, let's call it traditional or basic way to do it. Now, the language uses the Unicode character set. That's because the web is something which supports Unicode itself. I can use stuff like strings in Romanian with the letters which differ from the letters in the English alphabet without any problems. I can also name variables like that, but that's a bit of a worse idea if I want to share the code with the world. Anyway, it's case sensitive. This is a bit less relevant. Now, this is me declaring a variable, which is var a. Now, I can declare variables in two ways, which is var and let. And we're going to investigate this for a bit. And I can also declare constants, in the sense that constants are going to give me an error if I try to modify them. But it's just, let's say, a hint to the interpreter. Now, this allows us to talk about something interesting. So now, on a future slide, we're going to have the idea that although JavaScript is not a purely object-oriented language, it's, let's say, highly object-oriented. It's a lot more object-oriented than you might think. What would a purely object-oriented language mean? Everything is an object. Yeah. No, the classes don't work into it. Right? We're going to see that, you know. But yeah, everything is an object. Now, not everything is an object in JavaScript, in the sense that I have some primitive types, which are not objects. But as opposed to other languages, which you might call fully object-oriented, or, you know, a lot more things are objects, right? Things that you might not think that are objects are objects. So libraries are objects, functions are objects, arrays are objects. And in a low-key way, namespaces are objects, right? So a namespace in another language might be an abstraction, right? Something which says this is where the variable is visible. Now, as an additional question, if I declare a variable in C or in anything else, where is it visible? In the not the scope. So how large is the scope? Let me put it like this. In the block where it was declared, right? That's called block scope, right? Well, the difference here is that, so if I do something like let b, this is visible in the block where it was declared, right? But if I do something which is var a, like this is visible in the function where it was declared, right? So it's a function scoped variable. Now there's some utility to this, but it's really subtle. Making it an unintuitive feature of the language. This is why let appeared in conjunction with var. Well, if we want to have things more intuitive and have them block scoped, why still have var? Why is var still there? Well, the answer is that in contrast to other languages, in JavaScript has to be eternally backward compatible. There are websites which have been built in 1997, which are still on the internet right now, which have to keep working. Right? So whenever there's something strange in the past, the language is not going to deprecate it. Rather, it's going to give you a modern alternative, and you can use the modern alternative. But the old variant is never going to disappear, right? Because the site made by Joe in 1997, which sells carpets, has to keep working. Anyway, so that's var versus let, and to see the difference or the contrast, I'm going to do a for. This is one of the control structures, of course, and as I'm going to keep saying, this is going to be like in C. So let's do it with var. And I'm going to, this is the classic for, which counts from 1 to 10. It does nothing. But if I were in a language which was block scoped, what would I expect to happen when I try to read the value of I? Does I have a value? No. Well, unfortunately, if I do it with let, my intuition is correct. It doesn't exist. It existed in the block, but it doesn't exist. But if I do it with var, it's function scoped, which means inadvertently I've created a global variable, right? Which is why I'm saying that let is the more modern, intuitive thing. Long story short, use let. You only need, I don't know, it's you don't need to use var, right? Basically. Like I said, the differences are really subtle. And we're going to run into a future case for this. Now, a variable, like I said, this is dynamically typed in the sense that a variable has the type of what it contains, right? So if I were to think about b, which I've declared further up, and I'm going to say type of b, right? It's a number, whatever that means, okay? Right, but it's dynamically typed, so if I do b is some string, type of b is now string, whatever that means. Right, so I can change this, right? And I said that I can change it even further, but we're not going to go into that right now. So if I look on the left, though, so if b has the type of the thing that's inside it, what happens here? What type would A have?
Undefined, yeah. So the idea is that I don't know.
Right? So there's a further level of non-determinacy in JavaScript. Right? So in something like C#, right, I'm going to have a box. I know the type of the box, and the box might not contain anything, which in practice is going to mean that it's going to contain a special value of null. If I think in C, that means literally a 0 pointer. Right. Whilst here, I can have something else I can't know, right? So I don't know the value, but I also don't know the type of the box, and that's undefined. I also have null, and null is going to mean I know the type of the box, but I don't know a particular value. The box doesn't lead me to something valid in memory. Right, so this is undefined. Undefined is a sort of special type in the sense that it's a marker type. It's a type with a single value. Why would something like this be a type with a single value? Well, because the language, like I said, is concrete. And there's no something abstract. It's an actual, the idea of not having something defined is an actual value. Right. So this, if I run it, I'm going to see that it's of value undefined and of type undefined. Like I said. Right. Almost a purely object-oriented language, like I said, because there are 3 primitive types. The primitive types, however, barring some special situations, behave like object types. Because I have auto-boxing. Do you know what auto-boxing is? You should have run into it at Java. I can always transform it. It's automatically transformed. It's the auto bit, right? So yes. So if I add an int 5 with an integer 5 in Java, that's going to work. Although I can't actually do that, right? It's not. If I didn't have auto boxing, this is not possible. The one is an object, one is a primitive. How does that work? And the way it works is that the primitive is boxed. It's wrapped into an object type. This happens in JavaScript, and whenever any primitive type is treated as an object, so for example, if on a primitive string I try to access a method, the interpreter is going to find a way to run it. And this is a common theme again, which is the interpreter is going to find a way to run it. This is what the interpreter in JavaScript does. It keeps trying to find a way to move forward. JavaScript is the only language I know where you can use a try-catch, which exists. We're going to see it at some point. So you can use a try-catch around the syntax error and catch the syntax error. Right? So even though it's a syntax error, which obviously you didn't intend to do, it's still going to catch it and move forward. Right? So, JavaScript. Like I said, this is it's a language with a lot of expression power. However, it's also quite dangerous, right? You have to understand what you're doing. It's not dangerous in the universal sense, but it's more dangerous than other languages. Right, it has simple and complex types, and the list of types is going to seem really small because I'm going to simplify it a bit and we'll get back to that, but there's 3 simple types and 2 complex types. Now, barring these marker types, which is null and undefined. I said I'm going to simplify it a bit because there's an additional complex type, which if we have time, we're going to talk about the list in principle. Right, so my simple types, which are the primitive types and the wrappers around the primitive types, are string, number, and boolean. My complex types are array and object, and I have the special marker types which are null and undefined, and I have something called symbol. We'll get back to symbol when we get to objects. For now, let's just move forward. So my strings, again, this is an oversimplification, and we're going to get back to this. But my strings can be enclosed in single or double quotes. The reason for this is to avoid the need for escaping. Right? This happens in a bunch of languages. So if I want a string which contains a single quote, I'm going to put it in double quotes and not escape it and so forth. However, again, with the C, sending to C, the language supports escape sequences just like in C. They're the same escape sequences, right? So \t is tab, \n is new line, etc. It's the same thing. And this is very much intentional, right? Now, numbers. Now, again, we're going to go back to strings. Strings are boxed, like I said, and strings can be also be treated as arrays. So I can iterate through a string and so forth. Numbers. Numbers are floating point. Now, this is another strange bit about JavaScript, which is the fact that it doesn't have integers. Right, so everything is floating point. This has a couple of consequences. Consequence number one is that it has to be, in terms of mathematical calculations, a relatively slow language. Because if you think about the organization of a microprocessor, there's a bunch of dedicated integer operations and a bunch of dedicated floating point operations, which happen in different areas, in different ways. There's a mode for floating point, a distinct mode in the processor. So, this means that if you were to build an interpreter, if you were writing the V8 engine, you would be somewhat limited in the optimizations you might do. You can't use the ints because they're not there. Now, the language does pretend to have ints from time to time, in the sense that, for example, there's a global function called parseInt, which is going to parse a string to a number, but it's lying to you. It doesn't return an int. It returns a floating point number without a fractional part. Now, the second consequence is that whilst int operations are precise, floating point operations are not necessarily precise. Right? If I have a floating point operation and it gives me a result which is a periodic number in binary, it's going to get truncated. Which means that given enough floating point operations, I'm going to have larger and larger loss. Which means that if I were to write financial software in JavaScript in the browser, I should not do it with numbers. That doesn't mean I can't do it. There is an object type, which is called BigInteger, which functions as an array of digits. Right? If you know decimal, the idea of decimals, decimals actually have a representation in the processor as well, which is representing a number as an array of consecutive digits. And there you have special operations, etc. Right, so, no ints. Right, so this is showcasing the dynamic data types, but we've already seen it, which is that I can change the type of a variable by putting something else in it. Now, before we go forward, let's get back to our variables a bit. Right, so let's declare A. So we have A. That's fine. A is undefined. And if I do, I can just evaluate them as is. So A is undefined. But if I do B, B is not defined. What would be the difference between A and B?
It's about hoisting.
What?
Hoisting.
No, it just doesn't exist. Hoisting means that every declarations that you do are basically put in front of your block of code so you can refer them, right? So if you think of having two functions, A and B, and A equals B and B equals A, a typical problem in antique languages is that you can't do this structure, right? They're circularly recursive. Right, in JavaScript you can do this. So hoisting means that the declarations of the functions are put in front of everything so that the calls have access to all the declarations. Now, let's think about it for a bit. So I said that many things are objects, even things that you wouldn't think are objects. But what is an object? Let's think abstractly a bit. So if I were to give a definition of an object, what would I do with an object independent of the language? No, because this doesn't have classes. So let's think what I do with it. Why would I want objects? What are objects good for? Those objects, what are they good for? They have what? Yes, that's a thing. But methods, I'm going to go a little bit deeper. What's the difference between a method and a function? What does a method have in addition to what a function has? Yes, it knows who this is, right? Yeah. It has this in C++ way of thinking, but in JavaScript it knows who this is. Because you can write this anywhere and it's not going to work, but you can try to access anything anywhere. Right, so a method has access to this, right? And this tells you that the general utility of an object is to group up behavior and state, right? Behavior is in the context of that state. So if you think about defining cat objects, right? So cat objects have an attribute called color, and every cat has this attribute, but the values are different, right? And all cat objects have a particular behavior, such as they purr, say. Right, so I group the purring and the meowing and everything with the color and the size and everything. Right, so that's what objects do. Right, so I want to group this up. So but I said something else in the beginning, which is, well, functions are values, right? So maybe functions are values, maybe methods can be represented as values as well, in some way. And then, if I think about the representation of an object, how might I represent it? Well, if I think about something like C++, where I don't have this functions are values bit, I'm going to have some distinct characteristics and some distinct behavior. But here, since functions are values, I can say that an object might be represented as a list of key value pairs, that is a dictionary, where the key is the name of the thing, color, meow, etc. And the value, well, the value might be a string, it might be a number, or it might be a function. Make sense? Right? So it's a list of key value pairs, the name of the things is the key, and the value, it can be anything, right? Any value. Right. So an object, so it's a list of key value pairs. So but if I think about this namespace I made here, might it be represented as something akin to an object? Well, yeah, so I have some names, which are the variables, which might have values, which might be numbers, or they might be functions. So the difference here, because I finally got to the difference. So the difference here is that on this list of key value pairs, which presumably is the namespace, well, A exists as a key, but B doesn't exist as a key. Make sense? When I try to access it, one of them works, one of them doesn't. Now, I know it seems like a bit of a stretch metaphor, but it's not. Because the namespace, the actual namespaces in JavaScript, are actually object-like. They're objects, but I can't get a direct reference to them. Although, we'll see when we talk about closures, I can get an indirect reference to them. I can actually sort of refer to namespace. But I can't say put this namespace in this variable. It doesn't work. Although that would be a really interesting feature. Right. Now, getting back from this tangent, I will have another type, right? Which is the Boolean type. It has true and false as values. What's interesting in JavaScript about Booleans? Well, first of all, where might I use Booleans? Well, generally, I'm going to use them in a place where a Boolean expression is evaluated, in an if, in a while, something like that. Well, in JavaScript, I can use anything there, right? Anything and everything has a Boolean value if forced to be evaluated to Boolean, right? It means that I can put a library there, I can put an object there, I can put a function. It's all going to work. Right. This leads me to the fact that if everything has a Boolean value, some things evaluate to true, some things evaluate to false. And this is actually specified in kindergarten language. So there's truthy and falsy values. Right? Falsy means they evaluate to false, truthy means they evaluate to true. And the list of falsy values is limited, and the rest of the things are true. So falsy values are false, obviously. The empty string, I don't know if this is not translated. The number 0 and minus 0, the reason why there's two of them is floating point. There's two values, right, floating point for this, depending on the sign. Undefined, null, and not a number. Now, not a number is, funnily enough, a special numeric value. Not a number is a number. It has a representation in floating point. So not a number signals the fact that an arithmetical operation or a conversion has given me something that cannot be represented as a number, right? So let's think about parseInt, right? If I do parseInt of 5, it's going to give me 5. ParseInt of 5.2 is going to give me 5. But parseInt of Penguin, it's not a number. Now, the reason why it exists in the characteristic of not a number is that it propagates. That means that there is no possible single or multiple arithmetic operation from which I can obtain anything else based on not a number. So I can't add something to not a number to make it a number. You know, there's nothing I can do to it is going to transform it to a different value. So it signals an error at any point in a string of operations. Right. So all other values are truthy. This is the test of this. You can run it yourselves. Now my complex types. So my complex types are arrays and objects, with the mention that arrays are also objects. I can treat arrays as objects. And there's that additional type which was called a symbol. We can actually not explain symbol, at least right now, without being in a context of an object. Symbols are not useful unless unless from using them with objects. Right, so arrays are zero-based, etc. They can be defined explicitly. You can see that that looks like a constructor with new, but they can also be, and generally are, defined like you see in the first line. Right, so it's just a list of values between a couple of square brackets. Now, arrays aren't actually arrays. I know it's confusing, but let's go through that. So, what is an array in another language? If I say array, what does it usually mean? Then they're arrays, but it's represented in a contiguous area of memory. What you've listed is what these are, right? Which is an array list, right? So an array list is a list which behaves as an array, right? So the array bit from this is the fact that I can access something based on position, right? But arrays purely, if you look at arrays in Java or anywhere, they're basically a list of an area of memory which is pre-allocated of fixed size, right? And there's a bunch of things of the same size which are packed one next to the other. Now, these are not that. These are array lists in the sense that the representation is like a list. But see what I'm saying? So they're called arrays, but they're actually array lists.
They're objects where the keys are the numbers.
Yes, they're objects where the keys are the numbers. Yeah, and they are always arrays of object. Interestingly enough, that means I can do mixed arrays. So I can have an array which has a number in the first position, a string on the second position, an object in the third position, an array on the fourth position. Right. So yeah, but apart from the fact that they're array lists, they also behave as queues and they also behave as stacks. If you think about it, it does seem is with everything on it, but it's actually really simple. If you want a list to behave as a queue, you just have to have the possibility to add at one end and take out elements at the other end. If you want a list to behave as a stack, you have to be able to add and remove at the same end. That's it. JavaScript arrays do this. They have 4 operations. You have removing and adding at the beginning, which are shift and unshift. And you have removing and adding at the end, which are pop and push. So this makes them be, everything. We'll get back to arrays. Obviously, this is not the limit of operations on arrays. We're going to want to look at operations which are, let's say, traditional and operations which are modern. But not quite now, further on in this course. Right, so objects. Right, objects, this is going to be a bit of an incomplete statement. So JS is a prototype-based language. Whatever that means. We're going to go into prototypical inheritance a bit further on, probably next time. Suffice it to say, it has inheritance, and there's a hierarchy of objects, and at the top of everything is an object called object. Notice that I say is an object called object. It's not a class or anything like that. Now, by the way, so the language is concrete. A classic language has a sort of blueprint for which to create objects of the same type. That's called the class. Okay? There's no blueprint in JavaScript. The definition of objects of the same type is an object. It has to be an object. It's a prototype. Right? So all other objects send to the prototype instead of respecting some abstract definition. And this is a consequence of it. Now, another thing which is built in is serialization. Now, the reason for this is that if you think about defining a language for the browser, serialization is not something that might happen from time to time. It's something which is core, right? Your applications are networked applications. That's it. You have to be able to send objects over the network. It's part of the core experience. Now, objects double as dictionaries or as hash tables in the sense that whilst an array maps a value to a number, an object is going to map values to a string. Right? So it's a list of key value pairs where values are mapped to strings. Now, let's see a simple object. So let's call it O, and it's going to be, it's pretty uncomfortable to write like this, but we'll deal with it. So this is O, and like I said, serialization and deserialization are built in, and they're based on something global, which is called JSON. So we're going to say JSON.stringify of our object, and we're going to notice the serialized part. Now this is the JSON format. The reverse of stringify is parse. The JSON format is the favorite object transfer way on HTTP. Right? It's everywhere. So this is the de facto way of transmitting objects. Well, you might argue for XML, maybe, but this is the de facto way of transmitting objects. And this is the native. So JSON means JavaScript object notation. So the native serialization scheme for JavaScript is actually how you generally transmit objects over the web. So if you serialize something in, say, C#, you're probably going to still do it in JSON, although it's not. But in JavaScript, you can actually take this bit from the middle and just put it in a variable, and it's going to function as an object. That's it. The only notable differences, which, since we're here, we're going to note, is the fact that strings are explicit. That means that if in my code I can define strings between single or double quotes here, I have to use double quotes. And the second bit, which is different, is the fact that keys, which are generally strings, are also explicit strings. See, they have double quotes. Right. So it's really well integrated with transferring stuff. When I say keys are generally strings in objects, I am referring to the symbol bit. Okay. This is what we've seen. Right. So objects are list of key value pairs. Some of the keys are, say, numbers or strings. Some of the keys are functions or can be functions. And we've already said what the difference between a function and a method is. Now, this is the declaration. This is not a method, by the way, and we're going to explain this shortly. And we're going to write a separate example to show you a method. So we have O, which has a bunch of characteristics, and the function f. Now, the definition of the function shouldn't be all that unintuitive, because if I think about defining a function in C, how does that look? Well, it's return type, name of function, list of parameters. There's no return type specified here, right, due to the nature of the language. So this is a solvable problem, but if I think about it, if I don't have a sort of marker word for defining a function, I'm going to find it hard to differentiate between defining and calling a function. Right, if I just say f or something. Or, well, it was harder at that point. There's a known solution to this. Anyway, so I defined the function, and some things to note. How can I call this function? Do I have to call it without any parameter? Can I call it with multiple parameters? What do you think? Yes, I can call it with no matter how many parameters. But if I have a function of ABC, and I call it with f of 1 and 2, what's C gonna be? Undefined. See, we're getting it. Right. So it's the language is really flexible. So the disadvantage is, can I have two functions doing different things with the same name? In JavaScript? No, because if I can call them no matter how I want. Right. So in JavaScript, all functions are basically variadic functions, right? That is, functions with a variable and unknown number of parameters. Okay? And the way that I differentiate between functions is through the name of the functions. How do I differentiate between parameters? What do you think? How do I know which parameter is which? Based on the position. But there's no type. Right? To showcase this, let's think about this function, and I'm going to ask you something simple, which is what it returns. What does it return?
Most likely concatenation.
Well, statistically, yeah, what you're saying is statistically a concatenation. Yeah, statistically, if I were to take all the cases of calling this function, it statistically returns a string. No, it returns a different value depending on what I give it, right? Because if I give it 3 numbers, it returns a number. If I give it something else, it's going to be a concatenation, what you're saying. Yeah. So 90% of the cases, yeah. So what I'm saying is that I don't know the return type. It depends on what the function does. Now, it might seem that not being able to overload functions is going to be a disadvantage, but it's actually somewhat of an advantage, because I can write a function which represents all possible functions. Right? And the function which represents the prototype of all possible functions is going to be this one. And we're going to get to this shortly. Now, why would I want to write a function which represents all possible functions? Well, because I might want to have some other functions which take an existing function and add something to it. They modify its behavior to some extent. And I can do this sort of something that's in JavaScript. Right, we're going to see some example of this next time probably. Now let's get back to our example. So I have f. What happens when I say let f1 equals f? I make another reference, right? Correct. Now, I said all the blue stuff is f1. What's the problem going to be here? There's a problem. So if I do all the blue stuff, it's going to work, right? It's not going to give me any error. It's going to say I am a function. That's fine. But what if I try to access this? Do you think it will work? No. No. Right. The function is unbound. It doesn't know who this is. We're going to see next time how I can take a function and actually dynamically bind it to an object. But for now, we're not going to trouble ourselves with this. But if I want to see, because the question becomes, well, how do I make a method? So let's stay at this relatively simple representation of objects. And let's say we have an object called O and P, person, right? Which has a name, this is Jim. And Jim has an age, let's say it's 28, and they know how to introduce themselves. Right, so if I were to do this, on the right of this property definition, I have to have some sort of expression which evaluates to a function, right? It has to be a function, so yeah. So this expression intuitively is going to look like this, or similar to this, because this actually says what? It's an anonymous function, right? Because it says function, no name, and the rest of it. So it's an anonymous function. So let's say it says console log, and if I were to just say hello, I wouldn't be able to say if this is a method or not. Right? How would I know? It doesn't try to do anything with this. I don't know. Maybe it has. Maybe it doesn't have access to this. But if I'm going to do this, hopefully write it correctly. So I am this dot name, and now I can do p.introduce. Right. So we're going to see that this works, and so it's very easy to define objects and their methods and all that stuff. Right. It's easy, but sort of I kind of would like something more, because what type is this P object? If I were to give it a name, I couldn't, right? It's an object. It's an object, generically an object, right? If I wanted to make a bunch of these, well, I could roll up my own solution, which is a sort of factory function which returns returns objects that look like this. But maybe I would like a way to define the type, right? I'd like a way to define the constructor of the type, basically, instead of creating my own idea of a constructor. So there's something missing from this. But if I want really simple objects, I can have them. Now, if I mention the constructor, we've seen some examples, and we saw that we can do something which says new something, new cat, new car, etc. So what's the difference between a constructor and a function? What if I don't have classes? What does a constructor? So a constructor. What does a constructor? What does new do? Let's put it like that. Yes, it allocates space for a new instance, right? Right. So a constructor is, if I think about what a constructor does in other languages, which are more formal, what a constructor does is somehow it allocates space for an instance of that particular type, and then it runs some code over that space so that it is populated. Make sense? It's sort of. So a function can do the same, but a constructor function is designed to have this pre-allocation of things, right? So if I run a constructor function and I don't have the allocated space, it's not going to work out. In simpler terms, what it does is it populates this. It populates this. So new allocates the space, and the constructor populates this. Right. So we kind of would like a constructor. We don't have it. I'm sorry. We're going to have it next time. I don't think we're going to reach constructors today. So, but this brings into view something else, which is in JavaScript, a way of looking at this whole thing is that I only have functions, and there are ways of using functions, right? So there are some functional usage patterns, right? So I can use a function as a method, I can use a function as a constructor, etc. Because I sort of gave away the plot, constructors are basically just defining functions in traditional JavaScript. Yeah, I don't know what this does. Right, because I don't think you can hear my voice better, right? Anyway, so I have some special data types. Before going forward, I said I was going to tell you briefly what symbols are. Did you play around with Python? Right, do you know the double underscore methods in Python? Okay, what are those and what are they for?
They are built in.
Okay.
Right.
Right. So let me clarify this. So it's they are part of what is an object protocol, right? So any kind of object has to respect this protocol. And if I think about double underscore underscore add underscore underscore, it means the same thing everywhere, right? What it means is overloading the plus operator in this case. Because you have operator overloading usable in Python. Right, so let's say you make a new language or you revive a relatively old language and you look at Python and you say, well, that's pretty cool. Let's do the same thing. But because you come later, you say, well, we're not going to imagine all the possible components of this object protocol, right? It's because Python says this is the rule of law, this is the object protocol, right? JavaScript doesn't say that. So what it says is you're going to be able to define your own object protocol if you want to. Okay. So the problem I'm going to have is if I have a bunch of objects and they all have the same key, which is underscore add, let's say, in this case, I don't know if it means the same concept. Does it mean the same thing? Is the intention for it to mean the same thing? I couldn't tell you. So what I would want to have is something which I can use as a key instead of a string, which I can uniquely map to a particular concept. And that's a symbol. Right? So it's a thing which is unique everywhere. So in practice, the object protocol of JavaScript is a lot thinner than Python's in the sense that there's very few things in it. But to give you an example which exists in the language, there exists something which is called symbol.iterator, which means this object is iterable. But I don't have symbol add and symbol context and all that jazz. Right. So that's what symbols are. We're maybe going to run into symbols when we're going to play around with Sequelize, but we'll talk about them when we encounter them if need be. Right. Now, when talking about operators generically in JavaScript, operators are going to be the operators from C in basically the same precedence order with a bunch of additions. Some of them don't really need to be discussed. So, for example, I don't have this operator in C, but if I were to reinvent C at this point, I would have this operator in C, right? It's an exponentiation operator. It has a corresponding hardware structure in the processor. There's nothing surprising about it, right? So let's think about let's talk about something more surprising, which is this thing. Now, in order to the prequel is just use the second variant because it's going to make your code a lot easier to understand. As an aside, you could try the following thing. When writing code for this particular subject, you could use a linter. A linter is a plugin, let's say, which is going to give you advice based on code style. So you can use a general coding standard, and it's going to pressure you into following a coding standard, right? There's a coding standard for JavaScript, just like there's a coding standard for Python, and you can use a live linter, and it's going to tell you what the problems are. And at this point in time, the first variant here is going to give you a linting warning. Right, so let's look at our situation. So we have A, which is a number, B, which is a string, And naively, we're going to assume that the operator from C does the same thing, and we're going to do A equals B. But there's a little mistake here. What would happen if I try to do something like this in another language? It wouldn't be allowed because they're not comparable. Well, what does that mean, to compare a string and a number? Unfortunately, or bizarrely, in JavaScript, this is going to happen. Not only they're comparable, but they're true. The comparison is true. Now, the fact that it doesn't crash with an error, this is a JavaScript thing, in the sense that, like I said, the interpreter is going to try to make everything move forward. For example, to give you another example, let's say I have an array of 3 elements, and I access element 6. What's going to happen in Java? You're going to get an array index out of bounds exception. Now here, it's going to be a value, which is going to be undefined. Yeah, so it's just going to work, but it's going to be undefined. Right. So from one perspective, right, these are comparable, but why is this true? Well, before this, like I said, just use the second one. The second one actually is going to give us what we'd expect, which is, and we can read it as they are equal and they have the same type. But for double equals, something strange happens, and it tells us something about the language. So the interpreter is going to look at 5 and the string 5, and it's going to want to compare them. And it's going to say, well, they're not comparable. I can't do that. So what might I try? Well, I'm going to try to box both of them. Now I have a number object and a string object. Are these comparable? No. So I'm going to try to convert them to string. And in this particular really niche meaning, those two are equal. But obviously, this doesn't make for readable code, right? So the way to do it modernly is to use triple equals, and its pair, which is not equal, right? So the reverse of the operation is not equal. Right. These are some conversions. We talked about them. So a conversion like this one is going to return not a number, because a kitten cannot be converted to number. Right. This is auto boxing. This is a primitive string, and I do it to uppercase. So this is going to work because it's boxed. So I have a bunch of operators. Many of them are intuitive. Let's see some which are not. So there's this thing, which is inline conversion of strings. There's delete. Delete allows me to remove a key from an object or from a hash map. Now these may or may not have significance at the time. So name in person is going to mean that the key exists in the object. Instance of is going to tell me if something is of a particular type, but we've not seen object types as of yet, so we're going to see them shortly. And this we've already referred to. This is the spread operator. Now the spread operator is going to take an array and it's going to decompose it into a list of values. This is what we've seen here. The ultimate function. The ultimate functions like that. And to see what it does, so I have A is an array, B is an array, so the array made of A and B is an array of arrays. Right. But what if I want an array of elements? There's this really simple way of doing this. There's an array.concat method. But if you want to showcase the spread operator, this is how I would do it. Right? So it's spread A. This is the values 1, 2, 3. And then spread B, the values 4, 5. Now, as for control structures. Now, control structures are the same as in C with 2 additions. So I also have the stranger bits, right? So I have ifs, just like in C. I have switches, which have breaks and all that, just like in C. So it's cascading switches instead of having something a bit different, such as a match. I have continuous, and I have labels and gotos. Don't use labels and gotos, but you have them. Right, so the for is the classic for, which is just that I don't have the type, I have a let. While and the while are the same. So what's left is this line. So I have for of and for n. So for of allows me to iterate through an array in a different fashion. So you've actually run into this probably. Did you run into a control structure which is colloquially called for each?
Yes.
Yes. What can I for each over? what can I put? So for each function is like this. So for each element of something. Okay. What's something? So what conditions does something has to fulfill?
There must be a class that implements iterable in Java.
Yes, in Java. Implements iterable means what? What does it have to have? An iterator, right? What's an iterator? It's a type which has two methods. It has a next and a has next method. Yeah. No, it's just this. If you're thinking about something more specific, you're thinking about something language specific, because iterating over something which has an iterator is while has next, next. Right? Well, next, and next extracts the next element. Right, so I have something similar in JavaScript. I can do this. It's called for-op. And we're going to see it. I don't have an example, so we're going to just write it here. I have an example, but I don't know which it is, so let's just, and I'm going to say for let element. Actually, I can actually do this, and I'm going to tell you why shortly. All right, so this works. Now, that can be a constant because what can I not do in such an iteration? There's a limit. There's an operation which is called unsafe in this context. I can't remove anything, right? So if I'm iterating over something, I can't actually remove anything in that process. If I want to remove something, I'm going to need the classic for, the one with the eyes. Right. So that's one thing. And the second thing is my second. Well, it was the first here for in. So for in answers a different need. So whenever I have hash maps, I have to have a way of iterating over said hash maps. How can I iterate over a hash map? Well, if I look at something like Python, the way I iterate over a hash map is pair by pair. But the reason why I do this in Python is because I have something which represents a pair. Do you remember what that would be? It's a tuple. A tuple is I can use a tuple to represent a pair. I don't have tuples in JavaScript. So, and the way this works is just like with the iterator, it has to have something which is called an enumerator, which gives me pairs. In this case, I don't have that. So what the next best thing is to iterate over the keys. And let's see an iteration over the keys and notice another interesting thing. So we have this sort of object, and we're just gonna do for const prop in p console log p of prop. Right, so this is going to work out. Okay, what? 1 sec. I managed to do it finally. Right. So it goes over this. I can see that I have a definition of the function. It's all fine. What's interesting is this line. Right. Let me go here so we can see it better. This line. So what's happening at this line? Well, because it's a p of prop, and that's a calculated property, right? So instead of using the property in the sense that giving the name of the property, supplying the name, what I'm actually supplying there is an expression which is evaluated to the name of the property, right? So would this work if I do something like this? Let's see. It doesn't change anything. It's the empty string. And the answer is yes. Right? So this is going to prove really useful because you can calculate the properties. In this case, I don't need to, but I can. And low key, this is reflection. This is reflection. So instead of having reflection like you have in Java, which is for serious people, here you have reflection which is really easily accessible. You can access reflection at any point. You can rewrite your object at runtime. You can do a bunch of stuff. To give you an even more interesting thing, you can take somebody's library, load it into memory, modify its behavior, and use it, which is called monkey patching. So, JavaScript has a lot of expression force. Right. So if you have any questions up until this point, if not, we're going to continue a bit. Not very. No, we're not going to do a lot more, but a bit more. But any questions up until this point?
When you have two objects with the same key that is a symbol, we can be sure that you have the same behavior, right?
No, but what happens there is that I'm establishing a convention as to what that might be. If I have two objects with just strings, I can't be certain that I got the strings in the same, they have the same purpose, so to speak. So it's just a way of organizing my code. Theoretically, at some future bizarre point, I'm going to have a bunch of symbols in the language. Theoretically. Practically, maybe not. So for example, let's take a trip into the future. Let's say instead of I want stuff like, I want a slice operator. If you know the slice operator in Python. We're going to see a function which does slice. But I want a slice operator. And I want to define the idea that an object might use the subscript operator, so the square brackets, to define a slice. I'm going to have a symbol that's sliceable or something. You know? So it leaves room for design, so to speak. To give you an example of this in practice, in Sequelize, the way that operators are represented, so operators in the SQL sense, right? So greater than, equals, etc. They're represented as symbols, so that in whatever context you use them, right, you can identify the behavior that is supposed to happen. But in the core language, there's not much. There's only a symbol.iterator and a couple more. So it's not. We can't really seriously talk about a language object protocol. It's not. You know, we could just fill the time, but not. It's not realistic that that's a full behavior of an object, like in Python. Right, so there's another kind of string. I hope this is still visible. There's another kind of string we want to talk about, which is this bit. I don't think it's visible, the characters are visible. So it's a string between back quotes. Back quotes are the quotes which are on the tilde key. And this is a string with a special behavior, and it covers some annoying little use cases. That is, it covers multi-line strings, which I might want if I want to keep any sort of indentation somewhere. If I don't have multi-line strings, it's really, really tedious. So I have to concatenate 30 strings so I can maintain the shape of the thing. So unpleasant. And it has something else, which is this bit. Right, so this bit is string interpolation. That means that whenever I run into an expression such as this one, $ curly brace, some name curly brace, what's going to happen is the interpreter is going to look for the S1 so that it replaces the expression with the value of S1. This is also really useful. There's also an extension to this, which is I can give it a function to actually format that. I can put a prefix. This is also really useful because you can do renderers really easy. So yeah, so it's truly syntactic sugar, right? It makes your life easier. It doesn't do anything really special. Now, something interesting though is that strings, to a certain extent, behave like arrays. So I can subscript them, I can for each them, etc. Even though strings, theoretically, like I said, even if they've been declared as primitive strings. Now, as for arrays, let's look over a couple of more methods, which are going to be from the, let's call it, classic interface. There's also a more modern interface, which we're going to briefly discuss, and this is going to lead us into next time. So first off, I have an indexOf method. Now, indexOf is going to, it's a method which functions full C mode, right? In the sense that it's going to return the first position of the thing I'm searching for, or something to signal that the thing is not found. Now, something to signal in this case is, that's why I'm saying it's in C style, is going to be a position which is impossible. Since arrays start with 0, a position which is impossible is -1. Right, so this is C-like. Now, the second thing on this list is slice. Now, what a slice is although there is a different implementation in something like Rust, but generally what a slice is a way of getting a copy of part of an array. It has to be a copy. Now the reason why I need a slice is that I have function methods which are destructive. Now that means they change the source. So whenever I want to do something which is destructive, I might want to do it on a copy of the array. Now slices have a somewhat precise definition in the sense that they give me all the elements with indexes in the sequence, which is specified there, where a sequence is an interval for integers, right? Right. And the sequence for a slice is always closed downwards, open upwards. The reason for this is that I want to be able to easily do this. This is a full copy of the array, right? It starts from 0, it's closed downwards, but it stops short of length because a dot length doesn't exist, right? It's beyond the last one. But I can slice anything, right? It's not necessary to get the whole array. I can get any part. Like I said, we don't have the nice syntax that you might have in Python, where you have the subscriptable slices, but we do have the functionality. Now the next one is called splice. Now splice, I know the names are pretty close, is something else. It's a Swiss Army knife for array editing, right? So what it does is it deletes some elements and inserts some elements. So from the first parameter is the position where I start. The second parameter is how many elements I delete, and the rest, how many elements, is what I insert in that place. And it's really easy to see in this context that they're not arrays, in the sense that I can insert 5 elements after deleting 2. I can also not delete anything, or not insert anything. Right? So this is why I'm saying it's a Swiss Army knife. I can find an element and delete it, then that's it. Or I can just insert an element, and so forth. And because it's a list, it's really easy. Okay. Now this is the what we're looking at in the classic interface. Maybe we should also talk about the idea of splitting and joining. These are a pair of operations. So simple string. So strings are going to have split. Now split is actually going to receive either a character or a regular expression. We're not going to talk that much about regular expressions at this point. If we need them, we're going to get into that. So what split does is, based on a separator, it splits a string into an array. Whilst join is the method on array, which is the pair for this. And let's say we join them based on this thing. Right. So this pair of methods also exists everywhere. So you can find it in PHP, you can find it in Python, etc. It's a pair of things. Right. So this obviously there's more methods for array. You can look at the documentation if you run into any. As per usual, don't hesitate to search for anything. Even the exam is open book, so you know. But there's a more advanced, let's say there's a bunch of methods which come from an advanced interface of array. And this advanced interface refers to what are called higher order methods or functions. Right? Higher order functions, higher order methods. So higher order functions, let's say, are functions which have an order larger than 1. But what would an order be of a function?
Having function as parameters.
Yes, a function with a function as parameter is a function of order 2. Right, and we're going to talk a bit about how I get to that. And I can have functions with functions of functions as parameters. And that keeps going. Anyway, but let's think about the following transformation. So it's I have a list of numbers, I want their squares. I have a list of strings, I want their lengths. I have a list of penguins, I want their names. Is there something common between these? Can I identify something common? Does this seem similar? I didn't hear you, sorry. No, it's the general shape. It's the general shape of the operation, right? If I think about how it would be processed, how would it be processed? I'm going to take, so I have a source, list of penguins, list of numbers, list of strings. And I'm going to take each one, and then I'm going to apply some sort of transformation to it to get an element of the result. Right? So for the first number, I'm going to get the square, then I'm going to go to the second number, etc. And if I were to write the general shape of this particular thing, I would get a unique function in which the variable parts are the source and whatever transformation I'm performing. But when I'm saying transformation, that's going to mean function. Right? The function is a transformation. So I can do this in one particular way with only changing the source and the transformation. So, and because this seems to be useful, I might give it a name. Right? This is a named higher order function which is called map. Right? So there's a bunch of these which have been defined on the array, and they cover the, let's say, typical use cases for higher order functions. We're also going to see the next time that it's trivial to implement a raw map, right? If we run into a language without map and we want to help the language, we can actually implement it really easily, right? So the idea is that this kind of thing is identified, which is an operation which abstracts many kinds of operations, and then I get this map function, right? Now, this abstraction process can go further and further on, right? So can I think about the map over, I can think about this is map over any array, right? But can I think about the map over dictionaries? No, reduce is something else, we're going to talk about it. But can I think about something which is akin to map over dictionaries? Well, I sort of can, right? It's because it's going to take a pair and it's going to transform the pair into something else. Maybe into another pair, maybe into... And this is actually something which is called a functor, right? So this is something which receives a list of things, a transformation, but also a type, right? And you can go further and further on. You know? If you want, I can put an interesting article about this, about what you can do with this sort of stuff in the course. Obviously, it's not for the exam or anything, and obviously, it's going to be pleasant or unpleasant reading depending on your interest. Yeah, so that's about it. We're going to stop here. So I'm going to stop the recording.